if you look at A, automatically, do you think of this as being sine or cosine? Sine graph, because it goes to the origin. What makes this different than the parent function of the sine graph? It goes up to 2 and down to -2. Where a sine graph goes from 1 to 1 normally. So using your terminology that we would have used with parent functions, what would you say is the transformation that's occurred here? It's a vertical stretch by 2. Right, I've stretched the graph by 2. In trig, we call that an amplitude change. Right? It still is a vertical stretch that's happened, but really, we've changed the amplitude. Does everyone remember what the amplitude is? The distance from the midline to the top is the amplitude. So now the amplitude is 2 instead of 1. Does anyone want to guess what the equation would look like for this transformation? If it has to be a vertical stretch by 2. That's it. This would be y. Can you guys see that green? Not very good. This would be y equals 2 times sine of x. It's on the outside. Outside affects the y's. And I'm multiplying the outside by 2. Any questions about any of that on A?
I have a question.
Yep.
Remember with logs, like you can move it to the exponent to the front? It doesn't work that way with cosine and sine. Okay.
Anything else? Okay, look at B. Just automatically looking, would you think this is a sine or a cosine graph? I would automatically think sine because it goes through the origin. What makes it different than a normal sine graph? Say again? So there has been a reflection over the x-axis. Normally sine waves start by increasing and then going through pi here and then decreasing to 2 pi, right? So it has been reflected over the y-axis. Reflected over the x-axis. So let's see. I'm going to write that down. Reflected.
Couldn't it also be a horizontal shift?
Could be. That's the thing with these periodic functions. There are several ways you can transform it to get there. Like this could be a cosine wave. And cosine normally goes, normally starts here at the hilltop. You could have just shifted it left. I mean, that's something that could have happened. Or it could have been, like you said, a reflection. Or it could have been a sine wave that we pulled from here. Like this is normally the beginning of sine. So say we just moved it pi to the right. There's not just one set way to tell. We're just kind of going over what some of these things would look like. So let's pretend like it was a reflection over the x-axis. What would that, how would we write that equation? Okay, this is how to think about it. Reflection over the x-axis changes the signs of the y values. Where do we change y values? Inside or outside? Outside affects y's, inside affects x's. So the negative needs to go on the outside. Anything else here on B? C. Again, because it goes to the origin, I want it to be a sine graph. That makes it easier. Okay, but what makes this different than the parent function of a sine graph? What kind of compressed? So it's a horizontal compression. Yeah, so let's just talk about what's happening, and then we'll figure out how we're going to write it, okay? Normally, we complete one full cycle in 2 pi radians. But now then we're going from the origin, we're going up to the hilltop, down to the valley, back to the beginning in only pi. So the period has changed. The period of pi is normally 2 pi. The period of sine is normally 2 pi, but now the period is only pi. So this is period changed from 2 pi to pi. And so again, we want this to be a sine. What's affected? The x's or the y's? X's are affected. So x's has to be changed from inside the parent function. And what happens when we're on the inside of the parent function? What did this do? Shift to the left, right? And what did this do? This was a horizontal compression by 1/2. Everything on the inside does the opposite of what it looks like it should do. Inside does the opposite from what it looks like it should do. So if we want this, we really want the period to happen in half the time it normally does. So if I need a compression, a horizontal compression, I need to multiply that x by 2. Like I said, we'll break this all down later. I don't know if it really wanted me to go into this much detail this early, but we're doing it today at some point. So, what about here? Yeah, it doesn't go through the origin, right? So it has been shifted up. It's not a cosine one either, because it doesn't even go through the x-axis at all. So if I move this back down to go through the origin, then what would we be looking at? Then it would reach a max of 1 at pi over 2. It would go through the origin at pi, bottom out at 3 pi over 2, and then end up back at the x-axis at 2 pi. So that's all that's happened to the sine graph is we've moved it up 2. So this is a shift up 2. And so what would that look like? Oh, I didn't even notice that. Look at number 2. Did you guys see that on number 2? So how many of those match up to what we've had? We wrote down D is sine of x plus 2, so we get that one. 2 sine of x is A, we get that one. Sine of 2x was C, we get that one. But then look at the difference for B. We wrote negative sine of x. They wrote sine of x minus pi. So what would x minus pi, let's write down what they have for that one. Happening on the inside or outside? Inside. Inside affects the x's and it does the opposite from what it looks like it should do. So minus pi means we have what kind of transformation? Shift to the right, pi. Okay? In trig, that's called a phase shift. It's the same thing. A horizontal transformation is a phase shift. So if I'm going right pi, we kind of talked about it on this one, didn't we? That could be something that could have happened. If this was the normal beginning of sine and it got moved right pi, we could have written it as y equals sine of x minus pi. So these two graphs are the same graph. So how do you know for sure which one was done? You don't. Okay, if you're having to pick from a graph, you're just having to make something of it. If you look at number 3, what does it say on number 3? It says, Kennedy thinks the graph sine of x minus pi could be written as y equals negative sine of x. Do you agree or disagree? And then we should see that we agree. If you shift the sine graph right pi, you would have the down bump. That's what they call it. I call it the valley or the trough. You have the down bump first, and then you have the up bump, just like a reflection.